Hello all. This is the first task given in the Sparks Foundation Data Science Internship. The first task is predicting the percentage of a student based on the number of study hours. These are the libraries which I have imported for this algorithm. Next, I have imported the data set and I have decided the dependent and independent variables. So the independent variable here is the number of hours of study of the student, and the dependent variable is the scores obtained by the student. The next step is splitting the data set into training and testing data set. I have divided 80% of data into the training data set and 20% into the test data set. So this is the entire data, this is training data and this is testing data. We can clearly see that the relationship of hours of studies versus the scores obtained by the student is linear. Hence I have used linear regression for this problem. The method I have used for finding linear regression is matrix inversion or normal equations method. In this method, the independent variable is converted into the feature matrix and appended by ones. So the final feature matrix which is formed is m cross n plus 1 matrix, where m is the number of data points whereas n is the number of features, which is 1 here. And the output matrix is formed by the y train, that is the output, which is m cross 1 matrix, where m is number of data points. So for finding the parameters, that is omega naught and omega 1, where the predicted line is going to be omega naught plus omega 1 x, is going to be found by the formula x transpose x inverse into x transpose into y, and this is the fitting of the line of y pred, which is omega naught plus omega 1 into x train. And this is the trained model, which is the line y is equal to omega naught plus omega 1 x, where omega naught has the value 2.64 and omega 1 has the value 9.814. And this trained model has been tested with the testing data set, and these are the predicted values and these are the actual values. So we can see they are more or less close, and then the evaluation matrix have been calculated, where the mean absolute error is found between the testing data set and the predicted data set, where mean absolute error is 5.632, and the predicted score for 9.25 hours per day, which was asked in the question, according to the matrix inversion method of linear regression, is 93.432. The next method which we can implement linear regression is the gradient descent method. So in gradient descent method, the main thing for visualization purpose is I have drawn the error surface. So for drawing the error surface, I have taken arbitrary values of omega 1 and omega naught, 100 arbitrary values of both, and I have calculated errors for each, and the error formula is y pred minus y train the whole square by 100, where 100 because 100 values of omega 1 and omega naught were taken. And this is the error surface which has been generated through this data, and this is the contour which has been plotted from this error plot, where each of this oval or ellipse represents one error. So in the gradient descent method, we start from one point on this error surface which is arbitrarily chosen, and small steps are taken until we reach the minimum error point or the minima. So I have initialized it randomly as omega naught and omega 1 as 2. The learning rate which decides how much steps we are going to take while coming down is the learning rate, which I have taken it as 0.01, and then error 0, which is the differentiation of the predicted y with respect to omega 1, and error 1, which is the differentiation with respect to omega 1 is found out, and until we reach the minima of the error surface, and the final values which we get are the optimal omega naught and omega 1. As we can see in this contour, we started from this point until we reached the minima here, and omega naught and omega 1 are found out to be 2.664 and 9.81, which is very much similar to what we had we had computed in matrix inversion method. These are matrix inversion method values. So again, this trained model is the strain model is tested with the testing data set, and the mean absolute error to be found out is 5.6322, which is also very similar to that found by the matrix inversion method, and the predicted score for 9.25 hours per day from gradient descent is 93.42. Hence, I have completed the first task and I have predicted the scores based on the number of hours of study of the student. Thank you.